Hello. Before I get started, I would like to thank Kasten for the opportunity to come before you and share our Leidos SecDevOps journey. My name is Craig King, and I am a SecDevOps engineer at Leidos. That title was given to me because I'm on the SecDevOps team. I've spent most of my career at Leidos. In all, I have more than 35 years experience in software architecture, design, and implementation. The majority of my career has been spent working in the federal space, a lot on command and control systems. I've been focused mostly on systems integration and data integration from different systems. I left Leidos about 2 months before my 30th anniversary. And then I spent the next 4 years working for a small company that was contracted to a Silicon Valley company known for doing massive data integration. I was responsible for performing data integrations across a variety of state and federal programs. And my last task that I had at that company was actually a commercial project where we were responsible for integrating data into a very large database and using that database to support data analytics for over 650,000 different customers. We ingested about 350 million records a day, and all told, there were over 850 billion records in the database. That particular database was a bit fragile and it liked to crash. So we really learned how to do the ops part of the DevOps by managing and maintaining not only that database, but all of the servers around it. In all, we had about 320 servers that we were managing, and we had a team of 5 people. We were also doing all the development of new software and maintaining and debugging all the old software. And that's really, I think, where I learned everything there was to know about DevOps from the point of view of doing the dev and the ops on a daily basis. If you don't know what DevOps is, or you need a little bit of a refresher, here it is. This is a typical diagram called an infinity diagram that shows the connection between the dev and the ops teams. So on the dev side, you have plan, develop, build, and test that go in cycles. And eventually you're going to release your software and deliver it to the ops team. They deploy, operate, and maintain that system and provide feedback. While it may look on this diagram as though this is sort of an iterative process that you're receiving feedback, maybe a week or 2 after you deploy something, it's really intended to be looked at from an agile practice where your dev and ops teams are together in the same scrum and they're communicating every day. So as we're planning, the ops team is in our plans and they understand what we're doing. And as they're maintaining, the dev team is listening in on their conversations and changing what they do accordingly. Typically, in a government space, you would find a very siloed environment. So the ops team and the dev team would be completely separate. They could be from different companies working on different contracts, and sometimes it's the same company and they still don't communicate. These silos are impediments to really getting to speed, security, and scale. You need to be able to communicate often, like daily, and you need to be able to see what the other teams are doing so that you can understand that what you do impacts the other team. The same can be said for the security team. The siloed approach to software engineering, it was just the worst thing you could even think of when it came to the security teams. Usually the development team wouldn't even be thinking about secure coding until after they developed and gave the software to the government, and the government would run it through Fortify and then give you feedback showing you that you failed to meet the requirements for security. And that's just the secure coding aspect of security. So it's really important to bring cyber and other security groups into your daily process so that you can start doing secure coding and static and dynamic analysis up front. And the ops team can understand the requirements for cyber, for monitoring and analysis. It's vitally important that everybody works together, and it's moving those activities left on the calendar, which has given this the shift left moniker that you'll see so often when you do a Google search. So we want to shift left security, we want to shift left ops, and that will ultimately lead to better speed, more security, and better scale. So our journey at Leidos in DevSecOps began when we understood that the development environment working in the federal space was very challenging. We would start up a new project and we would realize that, it was 30, 60, 90 days before we were really starting to develop. And so we got together and we decided that we were going to solve that problem, and we started working on a way to do it. And it was about that time that our CTOs said, security is important. Let's put security first. And they switched the acronym around. And at Leidos, we call it SecDevOps instead of DevSecOps. So again, starting software development on day one of a contract is hard. And one of the biggest reasons is regulatory compliance. And I'm going to talk about that just a little bit. Regulatory compliance has to do with what's called NIST 800-171 and Fips 140-2. And those requirements are extended to federal contractors whenever a contract has a DFARS clause in it. The DFARS clause will say that show you what you need to be compliant with. And if you have CUI data, that's controlled unclassified information, then you have to be compliant with NIST 800-171 and Fips 140-2. So what is NIST 800-171? Well, you can read that definition up at the top. It's basically saying that if you have CUI data, and if you've never heard of CUI, FOUO was what is now part of CUI. So it's that same kind of thing. It's government protected information. And those controls that are extended on NIST 800 cover the entire life cycle of software development, deployment, and management of information and systems. So it goes all the way from access control through maintenance, audit and accountability. So you have to be prepared to be audited by the government whenever you have any system that has a DFARS clause on it, and specifically to NIST 800 if it has CUI data. One of those things that is in there in NIST is what's called media protection, and that's where Kasten comes in for us. So another part of the regulatory compliance is Fips 140-2. It really defines how you do cryptographic, how you comply with cryptographic standards. So for us as developers, it really extends to encryption in flight and encryption at rest. So that's the important thing that we need to take into account when we're creating a system. A lot of that Fips compliance is handed to us through the operating systems, like RHEL and other operating systems, Ubuntu. When they go through Fips compliance checks, when they get validated, it can be 6 to 9 months of validation, and that is on a single version. So not all versions go through Fips compliance. So when you choose a version of RHEL, you need to choose a Fips compliant version. And it means that you don't get all the latest updates. So that is a challenge when building out your system. We have a case where we wanted to store data on an AWS storage device, and it was not Fips validated. So we had to go out and find a Fips validated solution that we could use to store data. So it adds a challenge into your environment. So how did we go about solving this problem? Well, we created a multi-tenant enterprise version of SecDevOps that we call SDO. We started work on day one with cyber, infosystems, developers, and Kubernetes experts to create an environment that met all the regulatory requirements. That took about a year to set up and document. And we established a system security plan that shows how we are in compliance with all of the NIST 800 controls. And that document is an auditable document that goes into excruciating detail on how we either comply with the requirement from NIST or how we can, through Leidos cybersecurity, use part of their existing controls to show that we're compliant. So we piloted and validated the system for a year, and then after that year, we started bringing in tenants, and now we have more than 130 projects or tenants, and we have over 1,600 users. We've recently turned it over to our information systems group, so it's no longer a development environment or an environment under development. It's now a corporate asset that's managed and maintained for the company. One of the things that enabled us to do that was using infrastructure as code. So we use a lot of Terraform, a lot of Ansible in order to manage and build our servers, and that can all be checked in and peer reviewed and modified as required to keep things up to date. So there is more, but wait, there's more. We recognized after doing this that a multi-tenant environment doesn't satisfy every project. One of the reasons is that, for example, Jira, there's a limited number of fields that we use when we are defining our workflows. So if projects want to have their own field for time, things can quickly get out of hand. You know, you have time in days, hours, you have time in you know, whatever unit of measure somebody wants, and suddenly nobody knows which field is used for what anymore. So we do place a lot of controls on how we can extend Jira to be managed with all of these different projects. It is a one-size-fits-all solution. That's not to say that there can't be some change as we go along, and we do a lot of customization. But we can't customize to the level that some projects want. So we are customized to what most projects need instead. So we decided to create a cloud agnostic version of our SDO that we call Portable SDO or PSDO. We leveraged a lot of the infrastructure as code from our enterprise version. We decided to be 100% Kubernetes. The only non-Kubernetes server in our system is the Bastion that we use to set up SSH tunnels for maintenance. We created it to be modular, flexible, and extensible. We actually created it specifically so that other teams within Leidos could add new functionality and have a very well-defined path for how that works. And we are aiming for 100% automation. That is absolutely possible when we are installing out into AWS all by itself. But when you go into even the Leidos internal environments or government environments, there are still lots of siloed teams that need to be brought in to have certain things happen, like setting up DNS or opening up firewalls and things like that. So there are certain things that can't be automated. However, we do, when we deploy into the wild, we can automate everything. So here's just a quick picture showing the complexity of our enterprise version versus the simplicity of our portable version. And I'll get into some of the details on that on the next slide. So just for comparison, our enterprise system has 7 different operating systems. So there's Ubuntu and RHEL, and there's Windows, and there's a few other things floating around in there to do everything that we need it to do. On portable, we use 1 operating system. On our enterprise, we have some Kubernetes that we use to run like Jenkins, SonarQube, and some of our other tools. On our portable side, it's 100% Kubernetes except for that Bastion. On the enterprise side, we have 44-ish instances, and I say ish there because when I was counting, I got 44 one time and 45 another. So I think it's somewhere around 44-ish. On the portable side, we have 6 instances. 1 is the Bastion, 5 go to Kubernetes, and we can scale those 5 out as far as we need to for projects depending on their size. On our enterprise side, we are mostly commercial software. Since we have such a large user base, we can sort of amortize the cost across all those projects. On the portable side, we didn't want to have every project have to go and pay for a GitLab license, enterprise license. So it's mostly open source. The only real exception there is our Atlassian tools, and that's sort of a bring your own license model. Most of our government projects have their own licensing for Atlassian, so that's pretty simple. And then within Leidos, we have an enterprise license, so it allows all our Leidos deployments to inherit our free, what's really ultimately free licensing there. The enterprise version has lots of different moving parts. The portable version is greatly simplified by having everything in Kubernetes. And then lastly, there's limited extensibility on the enterprise side. You can ask for a plugin to be brought in for Jenkins or Jira or Confluence, but if it's expensive and it's only for you, then the answer is probably no. On the portable side, you can spend as much money as you want and do whatever you want. So why not software as a service? And that is a great question. We are moving in that direction. However, not all SaaS services can comply with having CUI data. Even some of the services say, yes, we can use CUI data, but you start asking questions such as, what happens if you spill that CUI data onto another system? What if you back up our data and that backup ends up on somebody else's system? You know, there's all kinds of things you need to think about with CUI. It's really a big issue. So that limits the number of SaaS services that can be used. Just as a case in point, about 10 years ago, I was working on a Navy program, and we were given some source code for a certain system that had been around for a long time. And in fact, that source code had been given to dozens of contractors over the years. And all of a sudden we get a call saying they found that there was a piece of classified information used to initialize a variable inside that source code. So that became a classified data spill, and a CUI data spill really for us would have the same remediation. And that is every laptop or desktop that had a spinny drive in it, it needed to be wiped and zeroed. Any laptop or desktop that had a solid state drive in it needed to have that drive removed and have the drive shredded. And we had to go through some really interesting data cleanup on a VMware system that we had that was holding more than one project. And after probably a month and a half or two, we got to the point where we could say that we had cleaned up that spill. So if a SaaS service says that they can manage your CUI data for you, make sure that they can manage it if it spills too. As we move from our enterprise environment where we have infrastructure as code to our portable environment, we are really moving to what we're calling everything as code. That includes security as code along with everything else we're doing. And the real big reason for that is we want to have everything checked in to a source code control system, such as GitLab that we use. And we want to be able to peer review it, and we want to be able to manage it and maintain it and version control every change that we're making. That gives us a repeatability and consistency across all our deployments. For our portable environment, we're using a CNCF version of Kubernetes called KubeSpray. KubeSpray gives us the ability to be cloud agnostic as we install. And that also really helps with the idea of everything as code, because we can now deploy across multiple cloud environments using the same exact code base. For our containerization, we use hardened Docker containers. Those containers come to us through the Air Force project called Platform One. They have a repository called Iron Bank, and we replicate those images from Iron Bank into our own system. And then we put that into Harbor, and then we use Anchor to do continual validation and vulnerability checks on those images. So security is very important. We really have a security first posture, and we're doing all of that using configuration as code. So again, everything as code is important. It gives us reusability and peer reviewability, and it also pushes us towards being 100% automated. As I indicated before, that's not always possible in some customer environments, but if you're not thinking about getting there, being 100%, you'll never make it. So you got to have that mindset that you're going to automate everything, and then figure out how to push your customer, whether your customer is internal or external, to automate processes that they are doing manually and move them in the direction of infrastructure and security as code. Another big thing that we're trying to do within Leidos is that anybody who is within our PSDO ecosystem should be able to contribute back to our project. So we created our architecture to be very modular. We call those modules plugins. So every application is implemented as a plugin, whether it's Jira, Confluence, Anchor, or any other application. If you create it as a plugin, then it can be installed using our automation. So here's a list of the tools that we support within our portable environment. It implements a full suite of CI/CD tools. It also has lots of security tools in there. Mentioned before Anchor. We also use OpenSCAP that we can use to look at our operating system posture. And we use Prometheus, Grafana, and Loki for our monitoring and our logging. And then we can hook into our corporate logging environment and satisfy our cybersecurity through monitoring those logs. We use Keycloak as our identity management. Keycloak can be hooked into Active Directory very easily. And then for the applications, rather than hooking them all into LDAP, we use OIDC as it gives us a simple way of hooking applications in for single sign-on. I say simple. Fortunately, it was simple with K10, but not all the applications were entirely easy. We use Keycloak Gatekeeper as one way of doing OIDC, because we can sort of abstract away the application's knowledge of Keycloak using Gatekeeper, but we still have to jump in sometimes and write plugins or different authentication code in order to wire all those things together. But it is a sort of a tenet of one of our goals is that everything is going to be connected through OIDC, and that gives us true single sign-on across the application. So why did we choose K10? Well, one of the reasons goes back to NIST 800-171. In this case, the control CP10-4, as well as satisfies some other requirements. This particular control says basically that you have to configuration control your backups, and you have to protect the integrity of that data anytime you restore components of a system in any state. So K10 gives us that ability. We can encrypt the data, store the data on S3. We can have it versioned on S3. And we know that when we bring something back in, we know exactly that data has not been tampered with. And that is a vital component of complying with CP10. So another reason we chose Kubernetes, it really helps us have that idea of shift left, especially in terms of data protection. Rather than thinking about backups at the end of our deployment and saying, okay, now that I got this application running, how do I back it up? We actually think about it first. And we can do that simply because all we need to do is define a policy when we deploy our application, and Kasten does the rest, and everything is backed up. It can be, it's restorable, and it can be migrated to other VPCs. So there's a ton of capability that we get just by having K10 baked into our stack. Another thing it really gives us is it helps us with our compliance. So the more we can automate compliance and adhere to the NIST 800 controls, the more that's automated, the faster that we can get to an expedited authority to operate, or ATO, with our government customers. So that helps us get that compliance down from 45 or 60 days down to as little as a week. A couple more reasons why we chose K10. We compared it with Valero and other solutions. We found that Kasten was just simpler. It was simple to deploy. It was simple to understand the Helm charts. It's simple to integrate with, but it's very flexible and gives us, there's a lot of power in how we can do our backups. So for example, some applications have complicated connections with their own databases and other sources of information. We can easily create policies that get into the middle of that by quiescing a database before it does the backup, or moving data to another disk and then backing it up. All of that completely transparent to the application that we're managing. In my opinion, and the opinion of a lot of our customers, they love the user interface. It's modern, it's easy to understand what's happening, and you don't get lost in it. Everything is just right there and you can find your way around. And then lastly, they offered us great support. We called with a question about a particular kind of Kubernetes storage and whether or not they supported it. They got us on a call, said, you know, for the next call, why don't we instead give you a Slack channel and you can just ask us questions on that Slack channel. And I'll tell you that every time I've asked a question, I get a response back, sometimes in 30 seconds, sometimes in 3 minutes, but they always respond and they always answer my question. And even though sometimes I don't know what I'm doing, they sort me out and get me going in the right direction. So it's just really a great team. All right, so that's it. Thank you very much. I appreciate your time. And if you have any questions for me, you can email me at craig.a.king@leidos.com. Thank you very much.